All right, so you'll be able to watch this again later, okay? So
Right.
I'm just gonna run through the questions that you've asked, and as I run through them, I'm gonna do them, and you stop me if you don't understand something or if you need me to explain it, okay? I'm gonna try to get through as many of these as I can in the half hour, all right? And then you can go ahead and ask questions again. I'm sorry, you can go ahead and watch this again later on. Okay, so have you learned Sohcahtoa yet?
No.
Okay, Sohcahtoa is the little mnemonic shortcut that helps you remember basic trig functions, right triangle trig. So trigonometry basically is where when you have a right triangle trig, see how I have a right triangle here? When you have a right triangle, the relationship between the side lengths is related to the angle measures. So this angle measure right here, that angle measure is related to the side lengths of a right triangle. And it's specifically, in our calculator, we have a sine function. The sine of an angle is equal to the opposite side over the hypotenuse.
Mr. Dwyer, sorry, I can't see. Have you shared your screen?
Oh, thank you. You know what? I thought I did share it, but maybe I haven't shared it yet. All right, sharing now. My bad. Thanks for pointing that out. All right, can you see it now?
Okay.
You with me?
Yes.
Got it? Okay, so Sohcahtoa is what you'll hear people say a lot. So, S-O-H, that stands for the sine is equal to the opposite over the hypotenuse. Got it?
Yeah.
Ka, can you see my screen?
Yeah.
The cosine of an angle is equal to the adjacent over the hypotenuse. And toa is the tangent of an angle is equal to the opposite over the adjacent. That's what Sohcahtoa means. Just a little mnemonic that helps you remember the relationships, the three basic trig functions, sine, cosine, and tangent. So it only works when you have a right triangle. See how I have a right triangle? Yeah? So the sine of this angle, let's call that angle theta. The sine of theta would be equal to whatever the opposite side, that's the opposite, right? Divided by the hypotenuse.
Right.
So that's what the sine, it's the sine of an angle is the ratio. It's a ratio of numbers.
Right.
It's the ratio of the opposite side divided by the hypotenuse. Okay. Now, we don't know the opposite side yet. That wasn't given to us, was it?
Yeah, but we're not doing sine, right? We're doing tangent.
Right. I'm just I'm not looking at the problem. I'm just talking it through. Do we know the opposite side yet? We don't. And we're going to need this opposite side to do the tangent because the tangent is equal to the opposite over the adjacent, right? So they were talking about the tangent of D. So see, I called that theta. The tangent of D, or I could call it tangent D, I guess, if I want, but I'm calling that angle. Well, I'll call it D to be consistent. So the sine of that angle is equal to the opposite of the adjacent. Now, do you know how you could find this side? What other property do we know that helps us solve right triangles? Do you remember a very famous Greek man?
Pythagorean theorem. You can
Yeah. And what's the Pythagorean theorem say?
A squared plus b squared equals c squared.
Perfect. And what's my A and what's my B and what's my C? What do I have? I have two of them. Is 7 A, B, or C?
It's A.
Good. And how about 25? Is that A, B, or C?
C.
Good. So I can find B by solving this equation, or I can memorize very common Pythagorean triples. Do you know what very common Pythagorean triples are?
Not really.
Have you heard of 3, 4, 5?
3, 4, 5, yeah.
Can you think of any other ones?
Not really, no.
So it's good to memorize them because then you don't have to do this. If you knew the Pythagorean triple, you would know that 7, 24, 25 is one of them.
Okay.
But I'm not going to waste time explaining that to you. You can look that up on Google. Just type in Pythagorean triples and you'll see a whole bunch of them. Well, one of them is 7, 24, 25. But if you don't remember that, then you can use Pythagorean's theorem to solve it,
Yeah.
right? So we've got 20, we have b squared equals 25 squared minus 7 squared. I'm going to use my calculator. So 25 squared minus 7 squared equals 576. And if I take the square root of that,
We get 24.
I get 24. Got it?
All right, I see. It's not that hard.
Do you see how that worked?
Yeah.
So the opposite side is 24. So what is the sine of D? It's the opposite over the hypotenuse. Remember, your hypotenuse is always the one across from the right angle. And the opposite and adjacent, it depends on which angle you're looking at. If you're looking at D, then the opposite is 24 and the adjacent is 7. If you're looking at B, the opposite was 7 and the adjacent is 24. Got it?
All right.
So tell me what the tangent, so I did that, so now I'm going to make you do this problem. What's the tangent of D?
The tangent would be, okay, opposite. So it would be 24/7.
Very good, 24 over 7. And if it reduces, reduce it because it said in simplest terms, but it doesn't. And the reason I know it doesn't is because 24 is equal to 3 times 8, which is 3 times 2 times 2 times 2, and 7 is already prime. So nothing's going to cancel. So I know that that's simplest terms. That's what I'm thinking in my head. Okay.
Mm-hmm.
Good.
Yeah.
Moving on. Find the altitude of the triangle shown. Okay. So we have a triangle that's like this, and they want us to know the altitude. So the altitude means if I take a point and I drop it straight down and make a right angle with the base, that's the altitude. Well, they told me that all these sides are 6, which means it's equilateral, right? Which means what are the angles here?
60.
Yeah, there's 60-degree angles. So this is 60 degrees. Well, now I just dropped down. This is also 60 degrees. I dropped down a right angle. So what does that mean about these two angles up here? What do they have to be? If this is 90 and this is 60, what's this have to be up here?
30 degrees.
It's got to be 30, right? Have you learned in class about the little trick with 30, 60, 90 triangles?
It's that the
I'm going to show it to you real quick, okay? And you tell me if it rings a bell. If you have a 30, 60, 90 triangle like this, and if you're given the shortest side, X is what I'm given. So given, I'm going to write given X. Okay? If you're given the shortest side, then the longest side, which is the one across from the 90 degrees, right, is going to be double of that. And you can see it right here. This whole thing was 6, then this has to be 3. So this is half of that, or the biggest one is double the smallest one. Got it? So this would have to be 2x. And I'm going to save you the proof of this, but the medium length side is x times the square root of 3.
Yes.
Okay? Now, that's if you're given the smallest side. What if you're given the biggest side? I'm going to call it y. If you're given y, what would the smallest side be?
Y divided by
Yep. Did you say y divided by 2? Is that what you said? Good.
Yeah.
And then what would the medium length side have to be?
It would have to be
You
y.
multiply it by what? Multiply that smallest side by root 3. So it would be y times root 3 over 2.
Okay.
Got it?
Yes.
Okay. And what if you were given the medium length side? I'll call it z. This is the hardest one. If you're given the medium length side, you first have to go to the smallest side. Well, if I went from the smallest side to the medium length side by multiplying by the square root of 3, what's the inverse of multiplying by the square root of 3?
Dividing.
Good. So this side is going to be z divided by the square root of 3.
All right.
And then this side would be what?
2z divided by square root 3.
It'd be, you multiply it by 2, so it would be like this.
z2, okay.
Now you could simplify that some more if you want, but so this is also equal to 2 root 3 over 3 times z. You know how to do that?
Yeah.
Remember that? So this is equal to z times root 3 over 3.
Okay, yeah. And
Remember doing that? Okay, so now let's go back to our problem. It says find the altitude of the triangle. Well, that's this side. So
yeah.
let's call it x. So can you solve it for me now?
Yeah, it's 3 square root 3.
Very good. So x equals 3 root 3. Okay. Good?
Yeah.
All right. Number 3 says find the altitude of an equilateral triangle. I'm sorry, the altitude of an equilateral triangle. So now let me do red for this one since I kind of used this whole page. All right. Here's this problem. It says an equilateral triangle. Okay, so let's draw our equilateral triangle again. So if it's equilateral, what do we know about all the angles?
They're equal.
They're all 60, right?
Yeah, they're all 60.
And the altitude means if I go straight down, I have that special right triangle again, right? That 30, 60, 90 triangle. So now this, I'll erase this and make it 30. That's 30 right there. Got it?
Right, yeah.
And it said the altitude is 8 root 3. Find the perimeter of the triangle. So they want us to find, I want to add all the sides together. What should I do first with this triangle?
You should divide the square root by 3. Well, divide the number by the square root of 3, and you'll get 8.
Very good, because they gave me this one right here, right? They gave me that medium length side one. See how it's across from 60 degrees?
Yeah.
So divide it by root 3 and you get what?
8.
Good. And what's this full side then?
16.
Perfect. And what are all 3 of the sides?
6. Okay, I see.
16 times 3, which is 30 plus 18, which is 48. Got it?
All right, that's pretty easy, yeah.
Yeah. So that was the key, was to do that special right triangle. So same with this one right here. Actually, no, not the same. This we're going to use have you talked about geometric means yet?
Yeah. Yes.
So there's a formula for geometric means. Do you have your notes with you?
It was something like, I can't remember exactly what was the formula.
Do you have your notes with you or no?
No.
Okay, so I'm going to look it up real quick. Show you how to think through this. So I'm going to import an image and I'm going to look for geometric mean formulas.
Okay.
Hold on a second. Try that again. Geometric mean triangle. I think that'll give me what I want. Yeah. Do you see? See, which one do I want to use? There's actually 2 formulas that work for it. I want to see one that has both of them. This is why I ask you for it, because if you have it, it's written in a way that you're used to seeing it. And if I'm looking it up, it's going to be a little bit different. It's not going to be quite the same. Here's one right here.
Okay.
So here's the rule right down here, as you can see it. F is the geometric mean. The altitude is the geometric mean of the two parts that it splits up. Okay. See that? F is the geometric mean of the two parts, which means F times itself equals A times B, or F squared equals A times B. That's what it means to be a geometric mean. F times itself, F times F equals A times B. Also, in the picture like this, D, one of the legs is the geometric mean of the full side and the piece that's closer to it. So D squared equals C times A. Same with this one. See how that's at the other leg? E is the geometric mean of this full thing times the piece closer to it.
Okay.
So that's the rule that exists for these things. So let me sneak it just right here, and we'll do this one problem first.
Okay.
I'll leave it there, and we'll do this problem. So tell me what formula I can write based by, I'll do this one, and then you can do the next one. Okay. So what this is saying is that E, or one of the sides, is the geometric mean of the full hypotenuse and the piece of the hypotenuse closer to it. So that means E squared equals C times B, or D squared equals C times A. That's what that means. Okay. So this means, I'll write them here. D squared equals A times C. This means E squared equals B times C. And this means F squared equals A times B. So I'm going to use that property. I'm going to say 6 squared equals this full thing, which is y plus 9, times this first part right here. There's my formula, and now I solve it. We have a quadratic formula. So 6 squared is 36. Y times y is y squared plus 9y. Are you following me?
Yeah.
Do you know how to do this? I have to move the 36 over, yeah? You're good with this? You're good with factoring? If it factors?
Y would be y
Looks like 12 and 3 maybe?
12 and 3. Yeah.
Got it. So what can y equal? Either y plus 12 equals 0 or y minus 3 equals 0. So either y equals negative 12. Is that possible?
No.
Or y equals positive 3. Is that possible?
Yes.
Yep, sure is. And that's your answer. Okay.
All right.
So you want to try did that make sense how I did that?
Yeah.
I know I kind of did it fast, but it seems like you got that pretty good. Do you remember talking about that in class?
Yes, I remember.
Okay. Do you do a good job taking notes in your math class? Because that's the kind of thing you definitely want to have notes for.
Yeah.
Okay, so let's try this next one.
Okay.
So tell me what the equation is going to be.
So you're looking for that. So the equation would be F is the geometric mean of A and B.
Remember, this is the geometric mean of the full side and the piece closer to it.
Oh, okay, I see what you mean.
So what's the equation?
It would be E is the geometric. D is the geometric mean of D squared equals AC.
Okay, so tell me what to write.
It would be 10 squared
Mm-hmm.
equals 8 times x.
Not just x. 8 times x plus 8. Because
Oh,
this
yeah.
full side is x plus 8.
All right.
Do you understand?
Yes.
So that means 100 equals 8x plus 64. Subtract 64 from both sides. That's 36 equals 8x. And x equals 36 divided by 8, which is, think of 36 as 6 times 6, which is 2 times 3 times 2 times 3. I'm showing you the way I think about it. And 8 is 2 times 2 times 2. So a 2 is going to cancel and another 2 is going to cancel.
Okay.
So I have 3 times 3, which is 9 over 2.
All right.
That's how I like to do it. I teach you the right way to do things, or the best way. All right, moving along. Are we good with that? Those ones, geometric means ones?
Yeah.
All right, find the ratio. So now this looks weird because you're like, what? I don't have anything. How am I supposed to find the ratio? Well, you can make it up.
Oh,
You can make up whatever you want, right? So let's call this x. That would mean this is 2x, and that would mean this is root 3x.
yeah, root 3x.
Got it?
Yeah.
It doesn't, or you can just pick a number. You don't even have to use x. You can just use 1, right? Because the x's are going to cancel out. So what's the sine of 30? It's the opposite over hypotenuse. And the
So
opposite of 30,
1/2.
very good. The sine of 30 is 1/2. Good job. What's the cosine of 30?
So the cosine would be um
It's going to be the adjacent over hypotenuse.
so the square root of 3 divided by 2.
Very good. What's the tangent of 30?
The tangent
Remember
would involve
Sohcahtoa. So toa, O-A, O divided by A. What's the opposite of 30?
1/30th.
The opposite of 1. The opposite is 1, and the adjacent is root 3.
Oh,
So it's 1 over root 3.
1 over root 3.
Has he taught you how to deal with that yet?
Not really. Well, we're beginning to dive into this topic.
So to deal with this, you multiply the top and bottom by the square root of 3.
Okay.
And you get square root of 3 over 3. That's the way that they prefer you to write it.
Okay.
But your teacher may not make you write it like this yet. But that, just so you know, that's how you do that.
Okay, I see.
So what's the sine of 60?
The sine of 60. So 60 is
60 is going to be this one, right?
yeah. Would be
What's the
square root of 3 divided by 2. So it's the
yep. Sound familiar?
mm-hmm.
Yeah, the sine of 60 is the same as the cosine of 30, because 30 plus 60 is 90. They are complementary. That's what the in cosine means. It means complementary. Just so you know.
All right.
Okay, how about this? This
So
cosine of 60.
cosine of 60 would be 1/2, which
It'd
is
be the same as the sine of 30. That's right. It's 1/2. What's the tangent of 60?
the tangent of 60 would be square root of 3 divided by 1, which
is the square root of 3.
Okay. Okay.
Good. Was that it? Was that the last question?
That was it, yeah.
All right. Does that make sense?
Yeah,
I thought you had put more questions. That's why I was running through it fast.
I
Have you
know.
started the unit circle yet?
Unit circle?
Yeah.
Sure.
Not heard of it?
What is it?
So let me tell you what the unit circle is. The unit circle is essentially this, what you just did. It helps you understand what the unit circle is. So you're probably going to do this soon. So let me just kind of preview it for you. Okay.
Okay.
Because what the unit circle is so you saw that it didn't matter what the lengths were right there.
Yes.
Right. So if I take this triangle, if I take this, let me move it around a little bit. If I take this triangle right here and I put it inside a circle and I put the origin right here, and sorry, I'm getting ahead of myself. Here's my Cartesian plane. There's my x-axis and there's my y-axis. If I draw a circle and I make this distance right here 1 unit, and I draw a circle like this around it, a circle with radius 1 unit, this point right here is going to tell me the cosine and the sine of all my angles, of all my nice angles, like 30, 60, 90, 45, etc.
Oh, okay.
So what you're going to do is, here, you can help me fill this in. If this is 1, what's the side across from 30? What's this side got to be?
1. Well, it has to be 1/2. No.
1/2. And this, the longer side, is what?
1 square root of 3 divided by 2. No.
Yep. Yep, that's right. And so what's this point right here going to be? What's this distance, the x or the y?
X.
Yep, that's your x. So this is √3/2. And what's this distance?
1/2. The y.
That's your 1/2. Hey, and what did we just do on this last page? What did we say the cosine of 30 was? √3/2, right? There's your cosine of 30. And there's your sine of 30. So the unit circle is basically a circle that has a bunch of triangles inscribed into it so that the points of on the triangle are on the circle, and those points give you the cosine and the sine. So it's like a big old cheat sheet. That's what the unit circle is. It's a big old cheat sheet.
That's pretty helpful.
And yeah, and so like if I draw in this other triangle right here, and I make this a 60-degree angle, this point right here, this now is going to be 1/2, and this is going to be √3/2, right? So my point is 1/2 comma √3/2, and there is my cosine of 60, and there is my sine of 60. So the unit circle is just a really nice tool for you to find all of the sines and cosines of very common angles like 30, 60, 90, and more, because you could also take the same concept and draw it into the second quadrant, and you can draw it into the fourth and into the third quadrant, and you can draw these same triangles in these same quadrants. Like you can take this right here, and that triangle will be the same as that blue one. And the only difference is the points are going to be negative because it's in the fourth quadrant.
All right.
And that means that what this angle is right here, if I go, see how that was 30 degrees? You always start here, called your initial side. That's going to be 180 plus 30, because this is half, right? Half a circle. 180 plus 30 is 210. So there's that angle right there is 210. So this is your cosine of 210, and this is your sine of 210.
All right.
Watch, if you don't believe me. What's the sine of 210? Whoops, I'm in radians. the sine of 210. I said it's 1/2. Negative, sorry, negative 1/2. See how it's negative 1/2?
Yeah.
So that's what the unit circle is. All right. Sound good?
All right. Yeah.
All right. Well, hey, check out that video on my YouTube channel. You can find it on my website, and I'll see you tomorrow.